We'll just be talking about the carbon release planning for the OpenFlow plugin project, and with me is Shiva, and I'm Abhijit. And so the topics that we'll discuss quickly is first one is we had this thing called as the reorganization of the OpenFlow projects, we were let's go through the topics one by one. So the stabilization and bug fixing, performance, usability extensions, and OpenFlow 1.5. I've skipped OpenFlow 1.5 actually. One of the things that we used to have, we have been having, is that there are two types of models inside of OpenDaylight. One is one which is an abstracted system-wide models and OpenDaylight-wide models which were intended to be in the controller projects at the beginning of the time. Then there were the OpenFlow version-specific models. So these controller-wide models, they were intended to be supporting multiple versions of the OpenFlow protocol, as well as multiple versions of, as well as the other flow-capable protocols. So the idea was that we will have it more generalized so that people might be able to program flows via either netcon for OpenFlow or some other mechanism in the future. And the OpenFlow plugin would be doing this translation between these models. Unfortunately, or whatever it is, the other protocols or the other southbounds, they actually never added this OpenFlow flow-capable model support, and hence the abstracted models were moved into the OpenFlow plugin project. Additionally, the NSS, most of the ODL apps currently which work with the OpenFlow protocol and the OpenFlow plugin are actually working on the OVS, and which is an OpenFlow 1.3 plus switch. Now there is support for OVS. In the OVS there is support for OpenFlow 1.4, but even otherwise, most of the applications are 1.3 applications, 1.3 or above. So consequently, we have performance penalty for applications due to this abstraction, and which may not be really justified in all of the cases, especially for most of the apps which are OpenFlow 1.3 apps. Earlier in the year, around May timeframe or June timeframe, there was this discussion inside of the OpenDaylight community about we are having a lot more OpenFlow projects than and it's extremely confusing for a new user to see that there is an OpenFlow plugin project, there is the OpenFlow Java library project, there is the OpenFlow extensions projects, multiple of them, as well as we have the OpenFlow config and OpenFlow the table type patterns. So this leads kind of to so it's basically confusing to the user community. But the second thing with this was that you tend to have this performance impact due to this model translation that I mentioned before, and new developers would need to send or the developers actually need to push in the changes to both the OpenFlow plugin as well as OpenFlow Java repository. So let's say if we have to do an update for OpenFlow 1.5, we would need to push it two different places, and it's something which would slow down the development. And the proposal hence was that we should consider merging, at least to begin with, the two projects, OpenFlow plugin and the OpenFlow Java library. So OpenFlow Java library, if you guys know, It's mostly it's completely consumed by the OpenFlow plugin. It is not used by anyone else except by OpenFlow plugin, and it's a library that the OpenFlow plugin will use. So most of the low-level stuff is actually handled in the OpenFlow Java, like sending the packets out, etc. And the different flow form, the OpenFlow messages, etc. They are actually put into the OpenFlow Java library, and the OpenFlow plugin is responsible for the session management. So now where we are with respect to this. So I discussed this with with OpenFlow Java committer Michael Rehack, and the feeling from the OpenFlow Java folks that it has some pluses, but it's also got some issues. One of the pluses is that it will the future development is done in a single repo, so it might theoretically be faster for the developers to think. But a bigger problem is counteracting to the two repo problem is that OpenFlow plugin verification jobs take a long time. It's because they have a series of system tests. But OpenFlow Java verification jobs are very quick, like 2 minutes or so. So this begs a big question: is it possible? Like theoretically, if we combine these two projects together, is it possible for us to on the verification job on merge to be if you merge a code in the OpenFlow Java specific directories or folders, is it possible to run only those verification tests? So
why would that be an issue? Because not often we are going to change it in Java, right?
But if an OpenFlow Java developer wants to make a change, he or she needs to spend as opposed to currently he or she can just do a quick test and.
But going with the thing, I mean, mostly it's in the plugin that the work is much more than
Yes.
Java.
Yes.
Right? So,
Yes.
So
Most of the time it should not be that much of an issue, but still it's an issue that we need to think about. So so with that in mind, we thought we'll take it one step at a time instead of going all over the thing. And the step one, we thought we could work on a POC, which is this bulkomatic performance application that has been pushed into the OpenFlow plugin code repository. And it will it would just identify how much performance boost, if there's any, if we were to use the OpenFlow 1.3 models directly. So this POC, first of all, it will exclude any experimental integration in this initial POC. But the second thing is, if we really do see a performance gain in this thing, then we could expose these OpenFlow 1.3 OF Java models to the applications to provide a high performance OpenFlow 1.3 apps path. So the goal of the exercise is to have this OpenFlow 1.3 specific path available for consumption in nitrogen, and the bulkomatic POC could serve as a pattern for this high performance OpenFlow 1.3 apps, or updating the existing apps into to be using these OpenFlow 1.3 Java API directly.
would it mean you will still allow to have both the patterns?
Yes.
Because
Yes.
if you were to move from, say, OpenFlow
Yes.
1.4, then the abstraction thing is totally lost if you just expose them,
So the
Both the paths.
So the idea is that OpenFlow 1.0 and OpenFlow 1.3, there's a significant difference. So, but the OpenFlow 1.4 and 1.5, they are more. There's not much of a difference, and you don't have a complete rewrite of the protocol, and which makes it easier for us to going forward to make this as a single path. So, so additions will be as a superset rather than a complete different path. So, yeah, so the idea should be that the existing apps should continue to to work as is without any code changes, but if they choose to. I mean, most likely they will choose to, because most likely people, I mean, there are 20 plus projects which are dependent on OpenFlow plugin, and it's unlikely that most of them will actually change their code.
It's a choice.
It's a choice, yeah.
Code versus performance.
Yes.
Performance is a requirement for you. Go
Yeah,
ahead and
it's a
consume this
choice.
path.
Yes.
So
Performance is a requirement for you, and you have your switches are OpenFlow 1.3 plus,
3 plus, correct.
1.3 or 1.3 plus. So that was the plan. The second item we had was this stabilization and bug fixing. And yeah, there's nothing much to say. Just continue to fix the bugs during the Carbon release. So back to performance. If you look at these numbers, I got these numbers from Lewis's performance tests that he had, and roughly you see the key takeaway is that we have the beryllium design and the boron design. They have roughly similar performance. There's a little bit improvement here and or worse in some cases, but more or less it's similar performance. So in the clustering situation, however, the tests, or we tend to have a huge drop. So we need to look into that as a bug on. It's also possible that the clustering tests are a little pathological, but in terms of where the test is done and where the flow programming happens, which control the node. But it's something that we need to look into.
So when you said Ericsson is also having the same, you meant the lithium design, because this is the evaluation.
Yeah. So now we are calling it like, because beryllium had the helium design and boron has the lithium design. So
it's the helium versus the lithium.
yeah. Okay. Just substitute, because that's what is used in the performance report that was published by ODL in March, just after the beryllium release. So the designs were called different. So okay, the elephant in the room is that these the lithium design, or it has this current and future improvements and possible, like it's a cleaner design. It has the deterministic APIs and better stats collection, but still the performance is not really significantly any better than the earlier design. So that is something we need to look into a little bit. So there are several suggestions regarding this and on how to resolve this. They are on the next few slides. And what we discussed earlier about this OpenFlow 1.3 optimized API path. But we'll need to look into it. With this, I will give it to Shua to go through some of the suggestions that have come.
Sure, thanks, Abhijit.
Before I have a question, so
Yeah.
doing the inventory to topology model.
Okay.
Do we want to do that?
Not one of the suggestions was to retain the inventory model in the
Yeah.
plugin and still live with it. But we haven't had the thrashing out of the details.
Yeah.
I came late, so
Yes.
Sure.
Yes.
Yeah, so as Abhijit mentioned, for ensuring the performance improvements or taking steps as to how to improve the performance, one of the first things that we are planning to do is characterize the current plugin performance, as in what it is as of today, so that we know where do we have to move and what are the numbers we are looking at. So characterize the performance in terms of switch scalability, how many switches single plugin instance can scale to, and a single instance out in the cluster, and switch connection stability. So we did some tests internally, and for the Helium plugin it's good till 210, 240, but the lithium numbers aren't that good. So that is one area that we need to look into. The throughput in flows per second, so that's the provisioning rate. The reconciliation rate is something that that it was an interesting discussion with Anil and Louis that we came across, as in how fast, for suppose 1,000,000 flows, how fast do we reconcile? Because that can be an interesting use case in case we have traffic flowing on the switches, so that we know, okay, how much traffic drop do we allow, or how fast can we reconcile, and how much time it takes to provision flows. So those are the things we're planning to characterize the current plugin performance, and then have a discussion on where do we want to go, and find out the bottlenecks and fix it. The RPC to add bulk flows, yes, part of it currently exists. So there is a new application being introduced in the Boron scope. It's called SAP bulk flow add, bulk group add. So, but we haven't done much testing with it, so I'm not in a position to tell the numbers. So that is a nice exercise of pushing flows together to the plugin and to the switches. We need to test that out and find out issues and fix those. The final one is statistics collection. So now if we see in the earlier design also, it was a periodic stats collection for all the entities from the of just outputs, fix the bugs as and when they come. The usability part, yeah. So this is one interesting part, because for the past two DDFs we have had various questions on the usability of the plugin. One of the things that came along in Boron was the blueprint migration, but one of the things that we faced was, if we modify or if we reconfigure something from the rest, the container restarts. So if we have switches connected to it, that results in a lot of errors. So currently we have a couple of parameters in the OpenFlow plugin.cfg file, but we plan to augment all the configurable parameters with proper comments on how to use it and whether it will require a node restart or not, and a few new config parameters to be added, like tuning the LLDP packets, whether you want it or we don't want it, and the time for it to be sent. Flow installation or removal confirmation is one part that we have always thought of, as in if an application tries and provisions a flow, how does it know that the flow has gone to the switch or not? Currently, it's a bit difficult. So we need to find a mechanism in which we need to know whether the flow installation has been successful without the application polling it. A part of it is there for lithium, because in lithium, if you switch off the statistics and provision of flow, you can actually listen for a notification on the operational DS to see if the flow has been installed or not. Because on the RPC success, we go and write to the operator DS. So you can basically know, but that's with stats off. For stats on, you still go and poll it. So that's why I say part of it is there. So we need to see what it can be done. So feel free to put in your thoughts or discuss. We need to find a way of how can it be done. The statistics collection, as I already mentioned, yeah. So there has to be some amount of granularity control that has to be brought in the current design. It's all or none as of now. So
when you said you got to put it, I think the implementation is working for plugin polls.
yes,
Or the app has to poll
the app can poll it, or the plugin also polls it. The app can choose to poll it.
What I think is you have to still, application has to still register inventory, operational
Yeah.
inventory to know if it is done.
If it is done.
It
With
will be
stats off,
populated- It will be populated by statistics. Stats collection will populate it, but as an application, you still have to.
So I
register.
still have to check the
Yes,
operational
yes.
details to
Yes.
know that particular.
to know whether the flow has been installed or not. That's the thing. So for the statistics collection part, yeah, the granularity control is one thing which I was mentioning. So currently it's an all or none case. But if I require for a particular port or a particular flow, we don't have anything as of now. So that is one part which we try to enhance within Carbon. So because if you, one of the things that we have seen is with statistics of the numbers are pretty good. So if we can tune certain amount of statistics which we don't want or use them when we want, like kind of a watcher mode. So if you want for 5 minutes, yeah, I just want for 5 minutes and finish it off. Something like that. Yeah. So that is one part that we need to enhance or improve. So that is the work on the statistics which we are planning. This is an important part that comes in because currently with 2.6 OVS, this is an add or a mod instruction that exists that has been contributed. So if my switch already has some groups and the TCP connection between the controller and the switch goes down, and when it reconciles, I send the group adds again. So that actually fails because the switch have it. Now, it could be possible that the groups have been modified during the time the connection was not there. So we require some kind of a mod to be sent. Currently, for the controller part, the implementation is difficult because the controller doesn't know whether the switch is there or not. So we have a new action called as add or mod. So every time an application provisions, it will be an add or mod sent to the switch. If the flow exists, if the group exists, it will be a mod. If the group does not exist, it will be treated as an add. This is a new command that is coming in 2.6, so it would be a good to have because it does impact certain portions of reconciliation. And CLI support is something which, yeah, so I was listening on the OVS community as well, and I thought, yeah, it's a good thing to have because currently if I connect switches, I don't know how many switches are connected to the current controller instance without querying the REST conf. So if I can show all these connected switches, who is the master of this switch, because most of the times we require that information for debugging, and I wouldn't want to go and query to a REST or how many ports are there on the switch. So these are the few things on the CLI support that we think it would be good to have, again on a lower priority, but it would definitely make the plugin a lot more usable. Yep, Abhijit.
There are a few things that Tim was mentioning about being, that's okay, being able to have
Provision the flow and.
currently the flow, writing a flow, it takes a lot of code to write a single flow. So if there could be some kind of helper utilities which would help us do that faster for a new developer. So, I don't know whether
I don't think whether plugin is the correct portion that it will fit in, because it's more of a generic utility, so it's a genius.
no,
But yeah,
Genius is programmatically, if Genius there is utility already
Yeah.
available to do that, which will make it easier.
we have certain
But
utilities called as
I
MD-Sal
think,
util.
I think
So
the other thing could be like, say, from a CLI, which we used to have in hydrogen, is fill in certain values, so that you can quickly, from the CLI, so you can take it and.
yeah,
push
so
it
even from
in.
the REST you can do it. REST also, if you
REST
send
also
salvo
you can
service
do it,
add,
yes.
it works.
But, yeah, a CLI interface would
Okay.
probably be.
Definitely, we can
Because
take it
in
up.
the rest, you still have to fill in a JSON and it's not as.
Okay,
From
sounds good.
user friendly perspective, CLI would probably.
Sure. And one more thing that we found out during Boron was if we try to connect OVS 2.4 to, if we want to connect an OVS with a higher OpenFlow version like OF 1.4 to a current plugin, the handshake does not go through. So we need to ensure that the way the handshake happens, as mentioned in the OpenFlow spec, is correctly implemented in the OpenFlow plugin part, as in the highest supported handshake is honored, highest supported version is honored. So the handshake improvement is one part, and we need to be able to know what the device is capable of to work with other protocols. So on the handshake improvement part, we have certain amount of work. Yeah, so feel free to take up or suggest some things, and as a part of the work for this release. Apart from that, we were thinking of supporting some of OpenFlow features, OpenFlow 1.4 or 1.5 features like bundles as on top of 1.3 extensions. But again, that's on a very, very lower priority given the fact that we need to stabilize the current code base and ensure that it performs. So yeah, that is also a work item for Carbon in case we have a bandwidth. Finally, on the extensions part, yeah, so the current extensions doesn't have support for symmetric experimental messages. So messages, proprietary or extension messages which require a request and respond kind of a thing, we don't have it. So support of that would be good enough because that's the one piece which is missing. And we have certain portions, so if we want to add a new experimental, so the part of the OF Java encoding and decoding is still present within the OF plugin. It was discussed like it's a bit ugly because having the Java bindings within the plugin. So it's better if we could move part of that binding for the extensions into the OF Java project repository. It might not be very easy to start off with, but it's one thing that would definitely make the plugin much more usable and the framework much more usable in the coming days. These are the references for the performance tests that Abhijit spoke about. And I guess that's it. Any questions?
I had one question, but I was blocked because we moved on to the next topic. Where is the area that you have the maximum problems in terms of performance? Because VTN as a project uses statistics. It uses statistics for multiple things to know whether the port is up or down, to know if a flow is removed or not.
Okay.
So do you see much problems with statistics area?
What is the scale of statistics that you collect? And how
I
frequently?
don't know, that depends on the...
How much have you tested?
I mean, we have only tested what is the... And I just want to know the area of performance so far, the feedback that you have received, do you have problems making statistics?
Yes. Yeah, because if I have a million flows collecting statistics for a million flows every 3 seconds and writing them back to the operators, that is to understand. So in case you increase the number of ports, sure, if you don't have any questions, please feel free to take up tasks, attend the OpenFlow plugin meeting, and let's make this release much more stable.
I hope better.
Thank you. Thank you.
Due to this abstraction, and which may not be really justified in all of the cases, especially for most of the apps which are OpenFlow 1.3 apps. Earlier in the year, around May time frame or June time frame, there was this discussion inside of the OpenDaylight community about we are having a lot more OpenFlow projects than the and it's extremely confusing for a new user to see that there is an OpenFlow plugin project, there is the OpenFlow Java library project, there is the OpenFlow extensions projects, multiple of them, as well as we have the OpenFlow config and OpenFlow the table type patterns. So so this leads kind of to so it's basically confusing to the user community. But the second thing with this was that you tend to have this performance impact due to this model translation that I mentioned before, and new developers would need to send or the developers actually need to push in the changes to both the OpenFlow plugin as well as OpenFlow Java repository. So let's say if we have to do an update for OpenFlow 1.5, we would need to push at two different places, and it's something which would slow down the development. And the proposal hence was that we should consider merging at least to the other protocols or the other southbounds. They actually never added this OpenFlow flow capable model support, and hence the abstracted models were moved into the OpenFlow plugin project. And additionally the NSS, yeah, so most of the ODL apps currently which work with the OpenFlow protocol and the OpenFlow plugin are actually working and working on the OVS, and which is an OpenFlow 1.3 plus switch. Now there is support for OVS. In the OVS there is support for OpenFlow 1.4, but even otherwise, most of the applications are 1.3 applications, 1.3 or above. So consequently, we have performance penalty for applications. We'll just be talking about the carbon release planning for the OpenFlow plugin project, and with me is Shua, and I'm Abhijit. And so the topics that we'll discuss quickly is, first one is we had this thing called as the reorganization of the OpenFlow projects, and we were let's go through the topics one by one. So the stabilization and bug fixing, performance, usability extensions, and OpenFlow 1.5. I've skipped OpenFlow 1.5 actually. One of the things that we used to have, we have been having, is that there are two types of models inside of OpenDaylight. One is one which is an abstracted system-wide models and OpenDaylight-wide models, which were intended to be in the controller projects at the beginning of the time, then there were the OpenFlow version specific models. So these controller-wide models, they were intended to be supporting multiple versions of the OpenFlow protocol, as well as multiple versions of, as well as the other flow capable protocols. So the idea was that we'll have it more generalized so that people might be able to program flows via either netcon for OpenFlow or some other mechanism in the future. And the OpenFlow plugin would be doing this translation between these models. Unfortunately, or whatever it is,